So this is another limiting reactant problem. We have a balanced reaction this time, so we don't have to worry about writing our own reaction. But this time we have 3 reactants, and we have a huge amount, 5 times 10 to the 6th grams of each. So we're trying to find the mass of HCN and H2O produced. So we're trying to find like the theoretical yield of both of these guys. So we have 5.0 times 10 to the 6th of each one of these. And we're trying to find the mass of this and the mass of this. So it always helps me to write down what I have for each one, although this is a little bit redundant. Okay, so I have each one of those. Oh, we're out of focus. Come back. Okay, there we go. So what I have to do is I have to just start and do each one in order to figure out the limiting reactant. So I'm going to do 5.00 times 10 to the 6th grams. And we're going to start with NH3 just because it's first in the list. We're going to go 1 mole of NH3 equals 17.03 grams of NH3. That's the molar mass. Now I take the things right from here, okay? So now I have to go into both of these, and I can't do them both at the same time. I need to figure out which one am I going to do first. Uh-oh, we're out of focus again. I wonder if there's a way I can fix that focus thing. All right, let's see if that worked. All right, so I have to figure out which product I'm going to do first. And, you know, I don't know. I happen to know the molar mass of water, so I'll just use water to figure out the limiting reactant since I have to figure them both out anyway. If it doesn't specify, you can use either one. So I'm going to say, okay, I have 6 moles of H2O to 2 moles of NH3. And then I got 18.02 grams of water equals 1 mole of water. And if I calculate this out, I get 1.59 times 10 to the 7th grams of water. All right, next one, 5.00 times 10 to the 6th grams of O2. 1 mole of O2, the mass is 32.0 grams, and we get this right off the periodic table. Now I have to still use H2O because I started there. So I need to compare H2O in every case. So I still have 6 moles of H2O, and I have 3 moles of O2 here. Okay, so then I have 18.02 grams of H2O is 1 mole of H2O. This is the molar mass. And when I calculate this out, I get 5.63 times 10 to the 6th grams of H2O. Now, I still don't know which one's the limiting reactant. I still have to do the last one. 5.00 grams times 10 to the 6th grams. Oops, 5.00 times 10 to the 6th. I didn't need to put grams there. Of CH4. Now, I know that 1 mole of CH4 weighs 16.04 grams. I know that I have 2 moles of CH4 to every 6 moles of H2O. And again, I have 18.02 grams of water equals 1 mole. I'm going to re-emphasize again that every single conversion factor has to be equal to 1 because you can't keep multiplying by different things. So they have to be, the top and bottom have to be equal in order for it to be equal to 1. So 1 mole of CH4 equals 16.04 grams of CH4. That's the molar mass. They're equal. 6 moles of H2O here equals 2 moles of CH4. That's from the equation, and we consider them to be equal for this equation. And then 1 mole of H2O equals 18.0 grams of H2O. So each one of these factors is equal to 1. So we're not really changing anything here. So I just wanted to point that out because that's a mistake I see a lot on tests. So, all right, I have 1.68 times 10 to the 7th grams of H2O. So I have all these things, and I need to figure out which one's the limiting reactant. Now, it might be easy enough to go, oh, well, this one's the lowest number, but we have to look at these exponents. This means that there's an extra 0. This guy has one less 0 there. So this is like, like a whole power of 10 less than these guys. So the one with the least exponent definitely wins. This is smaller number. This is a smaller number than any of these guys. Okay, so this is the theoretical yield of H2O. Okay, this will be the one. And so that means that oxygen is our limiting reactant. I'm going to put limiting reactant right there. Okay, so that means that we can't use this guy in our equation at all, and we can't use this guy in our equation at all. We have to only use oxygen, who's the limiting reactant, in order to do any calculations. So the question asks what mass of HCN and H2O will be produced. Well, we figured out how much H2O would be produced. Now we need to figure out how much HCN will be produced. And we can only do that by starting again with the 5 grams times 10 to the 6th of O2 and just doing the calculation again. All right, so we have, again, 1 mole of O2 weighs 32.0 grams. Now we're trying to get to HCN this time. So we have 3 moles of O2 on the bottom and 2 moles of HCN on the top. And we have 27.03 grams of HCN to 1 mole of HCN. And if I calculate this out, I get 2.81 times 10 to the 6th grams of HCN. So this is the theoretical yield of HCN. And that is all the question asks.